So this is for Westlake High School in Dawson Oaks, Calculus AB, Chapter 3 exam review. I forgot to write the word review. It's black. Seems like it's blue here. Huh, interesting. Okay, so anyways, it says use the mean value theorem to show, that means for all x, when x equals 3, when f of 0 equals 3, and f prime of x equals 0. So show that that's equal to x equals 3. Let's take a look at some intuition or gut. It gives you this information right over here, which is f of 0 equals 3. This means when the input is 0, my x value equals 0, my y value equals 3. That's my y value right there. When x equals 0, my y value is 3. Or written in notation form, it's going to be 0, 3 point. So go through 0, 1, 2, 3, and there it is. It also tells you the derivative, which is my f prime of x, has to equal 0. My slope, my definition of derivative is my tangential slope function, right? That means my tangential function has to equal 0 for any value. So whatever the value of x is, the slope is going to equal 0. So, which makes sense, right? So when my y value, when x equals, for x equals 3, it should say x equals 3. Let me just check real quickly. F of x must equal 3. Oh, geez. F of x must equal 3. So suppose f of 0 equals 3. That's what I wrote right here. The f prime of x is equal to 0. There it is. For all x, use the mean value theorem to show that f of x must equal 3. My y value must equal 3. Okay. How do we, so any y value, for any x value, my y value must be 3. For x equals -4, my y value must be 3 as well. How do we use the mean value theorem? What does the mean value theorem say? The MVT, mean value theorem, says that slope tangent has to equal to slope secant at some c value, when the x value is some c. Let's see what this says, basically, all right? So you have a function like this. And I have x1 and y1. There's x1. And here's x2. My slope secant is equal to, here's my f of x2. Here's my f of x1. Sub says f of x2, y2 minus y1 all over x2 minus x1. That would be my slope, right? And it also says for value of c, where it's going to be tangent right here. Tangent here and tangent. And my slopes are going to be parallel. Slope, tangent are going to be parallel to each other, okay? So my slope secant must be parallel to my slope tangent. That's all it says. Some value of c. This would be like c1, this would be like c2, because this line is parallel to this line is parallel to this line, okay? So, how do we work this out now? We start with the secant slope, f of x2 minus f of x1 all over x2 minus x1. That has to equal slope tangent. What is the slope tangent? Well, we know that the slope tangent is located right here, right? The slope tangent is 0. This is going to be at 0, comma 3. Let's call this x2 and let's call this y2. So you can plot the x1, y1, doesn't really matter. F of x2, which is right here, that's my output. 3 minus f of x1 over x2 is 0 minus x1, that has to equal 0 on the right side because my tangential slope, they give it to you, happens to be 0. So when is the fraction equal to 0? It's when the numerator equal to 0, right? I can multiply by 0 minus x1 to the left side and the right side. 0 times x1, 0 minus x1. We can multiply that. That cancels with that. That equals 0 on the right side. So you have 3 minus f of x1 has to equal 0. That means my y value added x1 to both sides at f of x1. That's my y value. 3 is equal to f of x1. My y value has to be 3. And just like it says for all value of x, show that f of x, my y value is 3. Done. Okay. Don't forget, the secant slope has to equal the tangent slope. You can find the tangent slope. Sometimes they will give it to you. Sometimes you have to figure it out by finding the derivative. Good luck.